Christine's Butter Cookies sells large tins of butter cookies and small tins of butter cookies. The factory can prepare at most 200 tins of cookies a day. Each large tin of cookies requires 2 pounds of butter, and each small tin requires 1 pound of butter, with a maximum of 300 pounds of butter available each day. The profit from each day's cookie production can be estimated by the function f of xy equals 6x plus 4.8y, where x represents the large tins sold and y is the number of small tins sold. And typically what we do on these problems is we start with, well, let's label and say, well, what does x equal and what does y equal? And I know that's already in the problem right now, but I'm going to write it maybe just for myself. X is going to be the large tins and y is the small tins. The second thing that we do is we tend to write down what the profit function of this is, and that's our f of x and y. And in this particular problem, that value is actually given to us. It's the 6x plus the 4.8y. It means that they make $6 on a large tin and $4.80 on a small tin. And again, both of those things have been given to us. But what we're going to do in part A is we're going to write a system of inequalities to represent the number of cookies to be produced. And when we start, we need to remember that we need to assume that we're going to be making some large tins of cookies, and we're going to be making some small tins of cookies. But what seems to be the challenge on this problem is I'm always saying to look for what two things are happening in this problem. And that seems to be the challenge in this particular problem. But as I look back here, one of the things that stands out is it says each large tin of cookies requires 2 pounds of butter, and each small tin requires 1 pound of butter. And that happens to be one of our two things that's happening. Now it's hard to describe on this one. This is a little bit different from the other problems, but the other part is it says the factory can prepare at most 200 tins of cookies a day. So I did tins, and then I tried to write really small under here how many, which is easier said than done. And if possible, on your paper, try to write them side by side because we're going to have to put these in slope-intercept form to draw the picture. But if we go back to the butter thing that's happening in this problem, it says each large tin of cookies requires 2 pounds of butter. And each small tin of cookies requires 1 pound of butter. And how much butter do we have available? 300 pounds of butter. And that, again, didn't tend to be the issue in the problem. It was the other one. And it was back there in that, about the second sentence. It says the factory can make at most 200 tins of cookies a day. Well, that limitation here means that some of the cookies that we make are going to be in the large tin, and some of the cookies that we make are going to be in the small tin, but we cannot make any more than 200 tins of cookies. And for some of you at this point, you can say, I got the rest of this, I can do this. But what we're going to do is we're going to put this back into slope-intercept form. We're going to subtract 2x from both sides. And we get y is less than or equal to negative 2x plus 300. And we want to identify our slope and our y-intercept. Well, the y-intercept is 300. and our slope is -2. But remember, slope is rise over run, so it's -2/1 to help us graph here in a couple minutes. On the green inequality, I kind of have it squeezed in there, but we also need to put that one into slope-intercept form, so we're going to subtract x from both sides. And we get y is less than or equal to -x plus 200. And sometimes that causes people trouble, because what's the number in front of the x? And hopefully you're thinking 1, because it is. So for our green inequality, our y-intercept is 200, and our slope is -1/1. Again, slope being rise over run. And then we need to come over here and graph. And I know that I'm not using a ruler, but the rest of you have rulers. X is greater than or equal to 0 means that we have to cross the x-axis. This is a vertical line. And y is greater than or equal to 0 is a horizontal line. And you can't see it on your graphs very well with the pencil. But here's our vertical line for x is greater than or equal to 0. It's just actually x equals 0 at this point because we haven't shaded. And then here's our y equals 0 there. So you can see mine a little bit better because it's in red. But what this tells us here is that we're going to produce some tins of cookies. We're in the first quadrant of our graph. Then we go to the blue line and we see that b equals 300. So way up here at the top of the graph. And then our slope is -2/1. And I'm going to go all the way down to the x-axis, but that means down 2 to the right 1. 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 And it's helpful if you have the ruler. Down 2 to the right 1. And once we get that drawn in there, like I said, you have the ruler, so your picture is going to look better than mine. But there roughly is our y is less than or equal to -2x plus 300. We're also going to graph that green. The y is less than or equal to -1x plus 200. So we're going to go up here to 200 and notice that the increments on this graph, they do go in tens. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So here's 180, 190, 200. So you had to find it on there. It's hard to get those numbers in. And then our slope is down 1 to the right 1. Rise over run. Down 1 to the right 1. Down 1 to the right 1. And you with the ruler probably don't have to do all of these. It helps me a little bit with drawing a pretend like straight line, and that one's more crooked than not. But what we just formed here is we formed a convex polygonal region. And implied in this problem, it never says it, we need to shade. But the nice part is with those two red parts, there's no place else we can go. This is x is greater than or equal to 0. And you may want to wait until we get everything set up before you actually shade. But we don't have any place to go except for to the right. That's where they're going to be greater. Or y is greater than or equal to 0. It's going to be above. that line. What's causing a little bit of trouble as well on these is shading the blue and the green lines. And as always, pick a value that's not on the graph, not on that line. I'm going to pick 0, 0. When we put it back in here, it's going to be 2 times 0 plus 1 times 0. And the question is 0 plus 0 less than or equal to 300? And it is. And by the way, for some of you, this is very intuitive, but the X is kind of underneath the blue line, kind of to the left. So we're going to shade where it is. So we're going to shade here. We're going to do the same thing with the green. And I've crammed it in, but this is going to be 0 plus 0. Is that less than or equal to 200? And it also is. So the X, that black X is what we're looking at. So when we shade this, we want to shade where that X is with respect to the line, which is kind of underneath this green line. And ultimately what we get, before I really do shade, for our convex polygonal regions, is it's going to be here, and here, and here, and here. That's the area that I'm going to shade. Now, I find it helpful to use a highlighter, but the problem with the highlighter on the paper is that it bleeds through and then it makes it hard on the next problem. That doesn't mean that you can't or shouldn't use it, but here's the shaded region called the feasible region. And that leads us now, that was just part B. We came up with the inequalities. Part B, we drew the graph showing the feasible region. So now we're to part C. We need to list the coordinates of the feasible region. Well, one of the coordinates of the feasible region is that point right there. One of the coordinates of the feasible region is that point right there. One of the coordinates of the feasible region, I think, is right here. And one of the coordinates of the feasible region is right here. Those are our 4. So part C, 0, 0 was one of those order pairs. You do not have to have the same order as me. You just want to make sure to have all 4 of them. We have 0 and 200. This point right here, we have 150, 0. And then this point right here should be 100, 100. Which makes sense here because the problem says we can't make any more than 200 cookies, 200 tins of cookies a day. So this was our part D. And now what we're going to do is we're going to take these values and we're going to put them back into this inequality, or this equation. So when we start, we've got f of 0, 0. 0 is going to go back in for x. 0 is going to go back in for y. So it's going to be 6 times 0 plus 4.8 times 0, which is 0. Then we'll do f of 0, 200, which is 6 times 0 plus 4.8 times 200. And when we do that, we get 960. We have f of 150, 0, which is going to be 6 times 150 plus 4.8 times 0. And 6 times 150 is 900. And then we've got f of 100, which equals 6 times 100 plus 4.8 times 100, and that should give us 1,080. And this is going to give us the information that we need to answer this final question here in part D, which says determine the number of each type of cookie that is needed to make a maximum profit, and what is the profit. So we're looking at these values here, and our max, which I don't want in that color, our max is here at 1,080. That's our biggest number between 0, 960, 900, and 1,080. And what that means is that we need to make 100 large tins and 100 small tins for a total of $1,080 profit.